but I'm going to draw it and stop this whisker at the data. I have to go back and look at the data. The data value that was closest to this fence line, but within it. So that means I got to go back to this calculator, right? And I got to dive back into the data. I got to go look in L1. Which number in L1? Stat edit. Which one was the closest? Some of you may sort this, but you might find it. Who was the closest? All these numbers. Who was the closest to 54, but lower than 54? So closest to 54, but within it.
49.17.
Well, I'll go find it. By the way, there's a sort button for this if you want to sort it. Is that it? So if you're like, man, it was taking me too long to do this. If you want to follow me, you go, how do you sort on here? I'll hit quit. I'll just hit clear. If you go stat, before I hit edit, have you ever looked down here? What's this say?
Sort.
Sort A, sort ascending, sort D. So you go, all right, I'm going to hit number 2. If you want, you don't have to do this. If I go, okay, sort A. But guess what I have to put in parentheses? L1. L1, where is it on the front screen? You got to hit second one. I hit second one, and I go, I don't even close out the parentheses because I don't feel like it. Although you could. Done. So it did it for me. Let me go back and look. Stat, edit. Ah, thank you. Now it's sorted. It looks nice and pretty. Thank you. And which one was closest? Closest to 54.01, but with
49.4.
So in that number right there, I'm going to stop my whisker there. Does that make sense? So I'm going to draw this whisker. Here I go. Where am I stopping? Keep going, keep going, keep going. Where am I stopping?
49.47.
Right there. Right there. And I actually like to label it. I want to tell you, where did I stop? So if you're trying, like, I stopped at the value that was closest to the fence line, but within. So hey, probably the most common error on a box plot. Students mistakenly think this thing always reaches the what?
Outliers.
Fence line. Yeah. Now, could it reach the fence? It could. It doesn't happen often, but I have to tell you what would happen. It would have to be a miracle where, you know what happened? You and I found that number, and my gosh, that funny number right there is actually sitting in the what? Data set. Oh, okay, then draw it to there. Actually, you know what? That happens on your homework problems, so don't freak out about that. There's a cool problem on the ages of the presidents when they were inaugurated. You know, they're all like 46 years old and 54, and they got someone up in the 70s, you know? Like Reagan was really old, and James Buchanan was really old, but JFK was only 43. And let's see, Teddy Roosevelt, everyone, he became president when McKinley was assassinated. He was vice president, he was only 42. So you got ages around 42 to like 73, and one of the presidents is an outlier, and it's Ronald Reagan. So you can do that problem. But you're going to notice when you do it, you go, oh my gosh, the fence line is an actual number in the data set. All right. Hey, so help me do this with me. Does it go all the way to the 9? No way! And then you would be saying you got data way over here. Where do I stop? I stop at the number that's within the fence line, but closest to it. Which I guess in this case is going to be the what?
19.9.
Yeah, the 19.95. So I'm going to stop right there. And I'm going to label it. Awesome. Awesome.
So then our max is an outlier. Do we have to mark?
I love it. We have to mark it.
Okay.
So to finish this whole project, are we done? Well, we're like 99% done. There's one thing we have to do. We have to mark any outliers. You go, what symbol to use? I like to use an asterisk. I like to use this thing. But maybe you like hashtags. You can use hashtags. You can use any little symbol to represent your outliers. I said outliers because sometimes, Sierra, you get more than one. You get like 3 outliers and stuff, okay? But in this case, there's only one outlier. It was this time right here. Let's make a mark right here. Let's label it 54.63. But that little symbol means it's an outlier. Cool. If anybody in this room right now works for some organization or any company or something, you know what would be neat? Me included. I would like to see it for myself. A box plot for the employee salaries for the entire organization. From the lowest to the what? To the highest. Because I'd be curious, are there any outliers, right? And you can think about it in terms of myself right now. It's like, I wonder who would be an outlier. Are there outliers? All we need is all the data, right? And you go, yeah, but is that public information? Actually, it is. Actually, you can get that stuff. Okay? All right, so, is everyone okay with all this? Hey, we're going to do two things before you leave. The first thing is we're going to talk about the beauty of the box plot. And then the second thing is, let's talk about, can you use the calculator to do this? So the first thing, the beauty of the box plot. Why do I like these? Because they tell us stuff that's not in the histogram and stuff like that, the pie charts. This tells us about percentages. So, everyone, in this whisker right here, 25% of the data lies here. In this section of the box, 25% of the data is in there. In this section of the box, 25% is in there. And where's the remaining 25%? Because everything has to add up to 100. From here, I can't stop here though. Why? There's a what?
Outlier.
Yeah, so let me go all the way to the outlier. I'm like, all the way to there is the remaining 25%. This is the beauty of the box plot. I can look at a box plot and see stuff I don't see in the history. Holy cow, and listen to me. 50% of the runners ran between a 26-minute and a 37.24-minute 5K. I know that right away. So this is what I'm talking, you look at salaries, it's shocking. You're like, oh my gosh, half the employees make less than this amount. You're like, oh my gosh. Or half the employees, 25% of the employees? If I was thinking AECC, I'd be like, there's numbers up here. I'd be like, oh my gosh, 25% of the employees make more than this? I had no idea. So it really kind of stands out. It's pretty cool to look at some box plots. Plus, when you do comparisons, you put a box plot of men versus women, right? It could be cholesterol levels, something like that, but you're doing some kind of comparison. So the beauty of the box plot, percentages. Cool. Hey, do you all agree? Is this a true statement? 75% of the runners ran 37.24 minutes or less. Is that true?
What was the thing?
Oh, let me say it again. 75%, look at the picture. 75% of the runners ran that race in 37.24 minutes or less.
Yeah, that's true.
Yeah. 25% of the runners ran it in 37.24 minutes or higher. Hey, is this true? Half the runners, 50% of the runners ran that race in 30.95 minutes or slower.
True.
Right? Slower, I'm thinking quicker. Do you agree?
Mm-hmm.
I should say faster, right? Yeah, my apologies. I should have said 30.9 minutes slower, you're over here. And when 50% of the runners ran that race in 30.95 minutes or faster. True statement, right? Beauty of the box plot. But hey, maybe you want to build these with the technology. It's not hard at all. Let's go in here. I'm going to hit the lights, okay? Randy?
They will always equal 25% each.
Always.
Always.
Isn't that cool? Beauty of the box. That's what I like about it. You know, it's what I really like, Randy. We don't see this in a histogram. Now, unfortunately, I don't see many box plots given. But boy, are these cool. I'm being honest when you're talking about salaries. So this thing looks awesome if you're doing like NFL salaries. Or you're doing Major League Baseball salaries. See, Major League Baseball, you got a bunch of outliers. Because there's a few players that make a ton more than what? Other players. There's been times there when one player made more than the entire team.
Well, Bill
You
Gates,
know?
Bill Gates in his Harvard class.
So it is amazing, yeah. So we'll talk more about box plots. All right, everyone, go to your calculators. We already got everything in L1, right? Everything's already in there. So this is the first time we've been here. We want to draw a plot. We need a plot. The button is called Stat Plot. This is the first time I've ever gone here. I'm going to get off this screen by hitting second quit. I'm going to clear out this screen, and I'm going to hit second Y. It's called Stat Plot. So it's second in the upper left button. And the first thing I have to do is turn it on. Okay. I hit enter. How do I get the lock on? I just do what? I hit enter. There we go. Now look at these. Which one looks like a box plot? I see two of them. There's two of them. These two. Which one do we want? We want the one that's more scientific. The one with the outliers. Do you see it?
Mm-hmm.
The one with the little beep beep. It's got those two little outliers. That's the one we want. This would be one if it just didn't do any outliers for us, right? So that's the one we want. So let's go there. How do I move it? You got to use the left and right arrows to actually move it. Once you enter down, so I enter down, downward. Now I use the right arrow. There we go. Now how do I get the lock on there? Hit enter. Now watch when I hit enter. Everyone, you watch carefully. I'm going to hit enter. Watch what happens to this. Watch it change. So it says L1, L2 right now. I'm going to hit enter right now. Did you see it? It's a smart calculator. It knows that I've got everything in L1 when I'm doing Boxplots. Boxplots, it knows only to read one column. Well-designed calculator. It goes, okay, Boxplot, we're only going to read one column. Everyone, you okay with this marking for outliers? I am, it's fine. Now, hit zoom 9, because this will zoom in on your statistical data. Zoom 9 is called zoom stat. And I'm going to hit zoom stat to zoom in on my data. Zoom 9, all right, where's zoom? Zoom, and then I'll just go down to zoom 9. Zoom trade, no, zoom standard, I like zoom stat. And you enter. And there it is. Cool. Now, how do I get the numbers to pop up? I have to hit trace. I want to see the numbers, right? Doesn't that look like that? Yeah, it looks just like that. I want to hit trace. So I'm going to hit trace. And I'll use the left and right arrows.
What is
That's
trace?
what we got. Oh, trace is in the very top column, closer to the right, next to zoom.
Okay, go.
And then you can move your left and right arrow. Ooh. This is great. I mean, we did all that by hand, but this does it all for me. This is cool. And there's the lonely one. Outlier, there it is. We move back. And of course, when you do this, I do get students, they might be sitting here right now, and they're like, my calculator's not working. When class is over, come up and show, I'll help you fix it. It's probably, you know what can cause glitches? Maybe we got a brother or sister who uses this. Maybe you got like a toddler around the house. They love to get in these calculators. And if they go into like the y equals and put stuff like this, that kind of stuff can throw it and lock it up. So I'm going to make it clear. Sometimes this kind of messy stuff can make it lock and not work. So if I hit zoom 9, I got my little screen right there working. Isn't that cool? Hey, oh, one more thing. I might as well leave that up there. Last thing, I'm going to leave this up here so you can see this. Do you remember skewed left, skewed right, and symmetric? All right. Head on. Zoom 9. We go, what does that mean? Well, if you got data that looks something like this, that's going to be skewed to the right. If you got a box plot that looks like this, where it's longer whisker on the left side, that's skewed to the
Left.
left.
And the center.
And what do you think this would be if I've got a box, the median is almost roughly in the middle of the box,
Bill.
and this whisker is almost the same as this whisker? What do you think that would be?
Bill.
Bell shape. So, everyone, what would you interpret that one on a test? What would you
Bill.
say? And you can use the word roughly if it's a close call. You know, if you're not, that's roughly what? Skewed to the, I think it's roughly skewed to the right. Now you want to make sure? You want to have fun with this? It only takes 2 clicks of the calculator. Can you see that art or should I hit the lights?
Hit the lights.
I'm going to hit the lights. I want to have a little fun to make sure this is skewed to the right. So watch what I do. I go, I want to make sure, is this skewed right? It looks skewed right. I'm going to go back to stat plot. Hit enter. Which one of those looks like a histogram? Which one of those?
Third one.
I'm going to hit this and hit zoom 9. Oh, it's skewed to the right. Oh yeah, baby, right? Now this thing's skewed to the right. Can you see that? Do you agree? Now, see, I can just change. You could change from a histogram back to what? Oh, let me put it back. I'll go back here, down here, and put it back to my cool box plot. Zoom 9. You can go back and forth. But I want you to see skewed right, skewed left, symmetric. Man, everyone, great job today. If you have calculator issues, I left some time here. You come on up. I'll help you out, all right? Have a great day. Stay safe driving.